t does not have to represent time. But in a lot of applications, it does. Now here's my first example I'd like to do. I'm going to start it on a new piece of paper. So I have x equals t squared minus 2t, and I have y equals t plus 1. And we're going to sketch this parametric curve. Okay, I went to a new piece of paper. I'm going to put this on the document camera. Not for you to start writing as fast as you can, but you can kind of see how to plan out your paper. I'm going to do a chart. We're going to grab those ordered pairs and we're going to plot them. Okay? So, I'm thinking of a T-chart similar to what you've done for years and years, but this is not just a simple T-chart. You're going to have a column for t. You're going to have a column for x, which is t squared minus 2t. You're going to have a column for y, which is t plus 1. And then I'll put in a fourth column, my xy pair. And we're going to plot the xy pairs, connect the dots, and that's our parametric curve. So I've picked these values, and you can pick, just like when you did those T-charts, you kind of had some freedom to pick. And so I'm going to start -3, -2, -1, 0, 1, 2, 3, and 4. And t might not represent time. Sometimes t might have negative values. Sometimes I might restrict the values for t. This time I want no restrictions. I'm going with this. After I see what I end up with, I might decide I need to pick a few more points, or I might decide that's enough. But when t is -3, what is x going to be? It would be 9 plus 6. It's going to be, see, that's -3 squared minus 2 times -3. 9 plus 6, that's 15. How about when t is when t is -3, what's y? -2. The pair is going to be 15 comma -2. Now, I kind of went off my line a little bit. Let me do that for -2. Kind of get this lined up. When t is -2, what is x? X will be 8. You can check that out by plugging in -2. When t is -2, what's y? -1. The ordered pair is -2, -1. When t is -1, x is 3. Check that out. In fact, y'all go ahead and start plugging in these t values. Which one?
X is equal to 8.
Oh my gosh, yes. Thank you. let me change that, plus 8. Okay. All right, now when t is -1, then x is 3. What is y? 0. So the pair is going to be 3, 0. When t is 0, 0, 1, 0, 1 is the pair. When t is 1, x is -1, y is 2, -1, 2. When t is 2, x is 0, y is 3, 0, 3. When t is 3, x is 3, y is 4, the pair is 3, 4. How about when t is 4? You get 8, 5, pair is 8, 5. Okay, I was kind of looking, well, I was looking back at what we did last semester, but you can check all those by plugging in those values for t. And then let's plot this. Now, I'm looking at my ordered pairs, and I'm seeing x goes up to 15. So I'm going to mark this off 5, 10, 15. And then the y values, for the y values, it looks like I'm good to mark it off by single units. 1, 2, 3, 4, 5. I'll put 6 up there. -1, -2, -3, -4. See, on the flip side here, -5 on x. So the first point that I had was 15, -2. The next one is 8, -1. So I'm guessing 8, putting it where, okay, 8, -1. And then 3, 0. 0, 1. -1, 2. 0, 3. 3, 4. 8, 5. Now, we'll connect the dots, and connect the dots in the order of t. I'm starting from here, and I'm going through like that. Now, that's what I've told you, but to make it easy to draw, I'm actually not going to tell you what I told you to do. I'm not going to do what I told you to do. Okay. It looks like what? A parabola. Now, here's the next thing that you have to be real careful about when you're graphing these. Do not put an arrow indicating it goes forever in this direction, but put arrows to indicate the way the particle is traveling. So when t was -3, it was right here. When t was -2, when t is -1, when t is 0, put arrows to indicate what's happening as t moves forward. If you put an arrow going the other way right here, you're going to lose points on the test. Okay, so here's a parametric curve. My next example